Today, we're doing all of chapter 12.
Please don't tell me to test.
Not this week.
That's after break.
After break.
Like the day after?
Yeah, homie.
Like how easy is that? Let's go.
Which one is easy, which one is hard?
10 is hard.
1.
Okay.
Oh, like
Yeah, I
actually?
can roll with that.
Okay. All right. So, we're going to start. With just a little bit of vocab. So, when we say a polynomial function, we mean something that can be written as like some leading coefficient times like x to the n plus some other leading coefficient times x to the n minus 1, blah, 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 all the way down to some leading coefficient times x squared, some coefficient times x, plus some constant term. All of these coefficients, all these coefficients are real numbers, and n has to be or all these exponents have to be non-negative integer values. In particular, when we talk about polynomial functions, we talk about a couple of descriptors, one being the degree. The degree is the largest exponent in your polynomial, and the leading coefficient is the coefficient on that largest degree term. So let's do a little vocab example here. So we're going to look at some functions that I've written down. We're going to decide if it's a polynomial, yes or no. And if it is a polynomial, we'll talk about the degree and leading coefficient. So A, is that thing a polynomial, yes or no? Yes, you said yes. Why?
It's got x's and exponents.
Okay, that doesn't guarantee that it's a polynomial, though. The exponents have to be non-negative anyways. And whole numbers. So if I have like 4x to the negative 6, not a polynomial. If I had 4x to the positive 6/5, not a polynomial. Everybody's okay? All right. So that's a polynomial. What's the degree? 6, the biggest exponent. What's the leading coefficient? 5 is incorrect. 4. It's the coefficient on the biggest degree term. Everybody feel okay? Yes. Good. That makes life easier when we remember things. B, polynomial, yes or no?
No.
You said no. Why not? So what? It's a coefficient. It's not an exponent. Nope. It is. Now, just to be clear, we have to be really careful here. Notice that the x isn't under the square root. If it was, it's no longer a polynomial. Okay, what's the degree here? Ava. Biggest exponent. 1 is correct. Where'd you get the 1 from? Right? X to the first, there's a 1 there, but we don't write it, but we know it's there. And the leading coefficient? Square root 3. Everybody okay there? C. Is that a polynomial? No bueno. Why not? Yeah, it's stuff under the square root, right? If there's a variable under the square root, it's not going to be a polynomial. Got it? Variable under the square root. D. Is that a polynomial? No, why not? Negative exponent, right? Can't be a polynomial if you have a negative exponent or a non-whole number exponent. You guys feel good? All right. So oftentimes we'll name a polynomial by the number of terms in addition to its degree. So what do we call a polynomial that has a degree 2? It's quadratic. What do you call a polynomial at degree 1? Linear. What do you call a polynomial at degree 0? Constant. And then if you don't have a degree at all, it's a 0 function. Still a polynomial, right? 0 is a polynomial, correct? All constants are polynomials. Everybody feel okay with what we mean by a polynomial, right? Easy vocab. Hopefully it's review. The next thing we're going to talk about is correlation. So say we have two variables like x and y, and we want to find out how strong the linear relationship is between those two variables, x and y. That's what we mean by correlation. Actually, let's do that, yeah. So in mathematics, we use the letter R to represent this term correlation. Correlation is a real number between 0 and 1. I'm sorry, negative 1 and 1. If R is less than 0, that means we have a negative linear relationship. If R is positive, that means that it's a positive linear relationship. And the closer we get, or the further we get from 0, the stronger that linear relationship becomes. So the further from 0 you get, the stronger that linear relationship becomes. When we get to exactly negative 1 or positive 1, that means it is a perfect linear relationship. That means that the x, y's that we have actually form points on some line. If we're at 0, that means there's no linear relationship at all. It's kind of a theoretical value. In practice, you're never going to see an R value of 0. But so let's look at some sets of x, y's and kind of talk about the correlations. So let's say we have two sets of xy's. We've plotted these on an xy axis. What's a plot of points called when we just plot some points like this? Scatter plot is correct. Good memory. When we talk about the strength of your correlation, basically what you're trying to do is look at, okay, how thick is like the line that I'd have to draw to kind of contain all my points. So that's not so thick, but if I look at this one, that one is like much thicker, right? That means the correlation there is going to be weaker. You guys kind of see that? Notice in this first one, our data is trending up as we move from left to right. That means the R should be positive. And here, the data is trending down as we move from left to right. Would mean the R is negative. Everybody's okay there? All right, so let's do an example here. So here's a scatter plot. Describe the correlation based on the graph and give an estimate for the R value. So let's start by describing the correlation. So there's two terms that you would want to have here. You want to describe the direction of it. Is it positive or negative? So this one is negative. And then is it strong, moderately strong, weak, moderately weak? I would call that strong as well. Correct. In not too distant future, we're gonna numericalize this so that there's like a numerical value to find, and then we can classify based on the number rather than the picture. So for right now, no. In the future, yeah. Okay. And then if we want to give an estimate for the R value, what do I know it has to start with? Negative. Okay. And I know it's less, or I know it's got to be bigger than -1, right? Because that's not a perfect line. What do you think? Closer to -1 is more line-like. Where would you say this one is? Yeah. I'd say it's much closer to -1 than 0.5. So I would say anything from like -0.7 to -1 would probably be some, or to, well, -0.99 anyways, would be something I would accept. So this is pretty good, right? So like, I don't know, like this should be good. You know, somewhere in there I would accept.
So we're just kind of guessing.
You're just guessing.
Okay.
Yep. The closer you're getting to 0, the worse it looks. If the thing is pretty tightly like a line, right? Like, you know, like that's pretty good. And it's probably at least a point or -0.8, probably closer to -0.9, to be honest with you. but like anything if you're ballpark.
How did you get on?
We guessed.
Okay.
We just guessed. All right. Let's do an example. Take out your calculator. Here's a data set. Everybody's okay with that? What I'm going to do with this data set is I'm first going to show you how to create a scatter plot out of this data set. Cool? So the first thing we need to do is enter this data into our calculator. To do that, I'm going to press the stat button, which is kind of next to the left arrow. From the stat menu, I'm going to pick I'm going to be in the edit tab, and I'm going to pick the edit command. And it should take you to a screen that looks like this, that has L1, L2, L3, etc. up across the top. You guys see that?
Are there supposed to be numbers in it or no?
Not necessarily, but if there are, that's okay.
Okay.
Anybody other than Maura have numbers already in their lists? Okay, so the way to get rid of your numbers, if you have numbers in your list already, listen, this goes for everybody. You'll maybe not need to do it right now, but you will later. See where my cursor is right now. I'm going to move my cursor so that it's on the title for that list. See how my cursor's on L1 now? I'm going to press the clear button, not delete, and then press the down arrow, and that'll wipe everything in that list. Removes the name of the list from the memory of your calculator, so you won't have any more L1, which means then you have to go put it back and then rejigger the order of your list or reset it's just a pain. You don't want to do it. Delete is for individual entries. Clear is for the list. All right. Ellie, Maura, you feel good? You got your stuff cleared out? All right. Now what I'm going to do is I'm going to type in my data for price of per can into L1 and the number of cans sold on a given day into L2. So I'm just typing the number and pressing enter. So again, just typed in the data into my calculator into L1 and then into L2. Anyone still typing? Yes? Okay. Hurry it up! All right. Now I'm going to exit out of here. So I'm going to press second and the mode button to exit to the main screen. Now I'm going to go to the y equals menu. Oh, not the y equals menu. I'm going to go to the stat plot menu, which is second y equals. Everybody's okay with that? From the stat plot menu, I'm just going to pick one of these. I'll say plot 1. I'm going to begin by turning it on. So I'll press enter to turn it on. What? I press second and y equals, and then pick the first option. It was 3 buttons. Stop talking to each other. Listen to what I'm saying. Follow along. And we won't get lost. I'm going pretty slow, but if you're talking in between, you're going to miss it. Okay? So I've turned on plot 1. The next option is the type. The first option here that's automatically selected for you is the scatter plot. That's what we're going to be using every single time. You take a statistics class, maybe you'll worry about these other things. You won't do that in here. The next option is the X list and Y list. Let's use the price per can, which we typed into L1 as our X list, and the number of cans, which we typed into L2 as our Y list. Does anyone have something here other than L1 or L2?
I have L5 and L6.
Great. So where it says X list then, Maura, you'll press second and the number 1, and that'll put L1 in place of L5. And you'll repeat the same process for your Y list, except you'll do second and the number 2. You're welcome. Got it? And then the mark is just like, what is the point going to look like on your calculator? I like the squares because they're easy to see. Oh, you guys have colors too.
Ooh, let's go. Mine's navy. Magenta.
All right. Now that I have my stat plot turned on and set up, I'm going to press zoom. Oops, I'm going to exit out and then press zoom. Second mode is always the exit. And I'm going to pick zoom stat. Mine was 9, but different calculators will probably have it numbered differently. So now we have a picture that looks like this. Does everybody have a picture?
Yes.
It's beautiful, isn't it? I love it, right? Okay, so there's our scatter plot. Fascinating, right? What we're going to do now, listen. What we're going to do now is construct a line of best fit. So what that means is we're going to create a linear function that's going to approximate the data on this scatter plot. Here's the good news. Our calculator is going to do all of the heavy lifting for us. Swell, right? So here's what we're going to do. We're going to start by exiting out back to the main screen. And we're going to start by doing something called diagnostic on. You should only have to do this once with your calculator unless you reset your memory or your battery dies. We should only have to do this the one time and not have to worry about it ever again. But if your battery dies or your memory is reset, then you would definitely need to go back and do this process again. So what we're going to do is we're going to press second and the number 0. That opens up the catalog. The catalog is an alphabetical listing of every operation on your calculator. The command we're looking for is called diagnostic on. So you could scroll all the way down to the D's, Or, if you notice on your calculator, there's little green letters above some of the buttons. If you push the button with the little green D over it, it'll skip you all the way down to the D's on the list. That saves me a bunch of searching. And now I'm going to just scroll down until I see diagnostic on. Has everybody found that? I'm now going to press enter. That copies diagnostic on to the main screen of my calculator. And I'll press enter again and it says done. I've turned the diagnostic on now. Yay! We don't have to you should never have to do that again. As long as you're using the calculator you're using now and your memory doesn't get reset either because of battery failure or choice. Everybody's good? Okay, let's build our best fit line now. To do that, we're going to press the stat button, which was right by the left-hand arrow. From the stat button, or the stat menu, I'm going to move over onto the calculate tab. And I'm going to choose the option lin reg, AX plus B. So I press that and I press enter. Lin reg, AX plus B. Now, my calculator gives me a menu. Wade, your calculator is just going to put that on the home screen, right? So I'll deal with you in just a second, but just sit tight and I'll tell you what to do. But yours can do everything that ours can do. The way you're going to do it is going to be a little bit different, but that's fine. All right, in the menu, this needs 4 inputs. We need an X list, a Y list, a frequency list, and a place to store the equation. So where are our X points listed? They're in L1, right? So the X list should say L1. Mine already does, so I don't need to do anything. More, if yours says L5, you should change that to L1. The Y coordinates we put into L2. That's what mine says already, so I'm not going to change anything. More, if yours says L6, you should change that to L2. The frequency list will always be blank for us. Nothing is ever going to go into the frequency list. Everybody's okay? The store reg EQ. This we're going to do something with. So the calculator is going to make an equation for us. This is going to give us the option of saving that equation someplace. We want to do that. We're going to save this equation into our Y1 so that we can graph it and compare it to the scatter plot we just made. Everybody good with that plan? So to get a Y1 there, this is what we'll do. We're going to start by pressing the vars button, which is just below the down arrow. Vars is short for variables. And because we're looking for Y1, we're going to move our tab over to the Y variables. Our calculator will always be in function mode for this class, so I'm going to press function. And I'm going to select the Y1 that's right there. Now I have everything entered into my calculator that I need, so I'm going to go ahead and press calculate. So Wade, your calculator says lin reg with a parenthesis, right?
Yeah.
Afterwards, you'd want to type in L1, so second, the number 1, and then a comma, which is like above the 7,
Yeah.
and then do second number 2 to get L2.
Yeah.
and then a comma, and then you're going to get the Y1 there. To do that, you're going to press the vars button, which is below the down arrow. Move over to the YVARS tab. Select function. Select the Y1 from that list, and then press enter to run that. Yep.
Okay, I got it.
So everybody should have this on their screen, right? These exact same numbers, everybody should have the exact same output from their calculator. Look at what one of the things listed is. Look at that bottom number. What is that? That's the correlation, right? That's the R value we were just talking about. Look, your calculator can compute it for you. That's awful nice, right? What else is it giving you? Well, it says for the equation y equals ax plus b, the a is negative 104.6 yada, 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 right? And the b is 329.2 yada, yada, yada. So it's giving us that equation for a line. Yes, sir. Okay. I'll take a look at it in a minute. Does yours say y equals ax plus b, or does it say?
Oh, it says A plus B.
That's so you just pick the different regression, which is fine. You still have the same equation because the b is the slope instead of the a, so it's fine. But in the future, be careful about that, which one you're picking. All right, everybody's okay? What I want to point out to you, let's look at what we have now. If we press the y equals button, look at what you have in y1. What is in there? What do we find in there? That's the equation the calculator just made for us, right? It typed it in there all on its own with all the decimals. That was pretty nice. And if you hit graph now, there's our line of best fit. That line approximates the data. Pretty cool, right? What if I had asked you to use that line of best fit to approximate how many cans we'd sell if we charged $2.15? What am I asking you to do? I'm not asking you to change any values. What I'm asking you to do is to plug $2.15 into that equation that we just made and figure out what the output is, right? Guess what? Calculator will just do this for me. Since I stored that equation into y1, see it's still there, I can use that y1 like a function notation. So I'm going to go ahead and retrieve the y1 and put it on the main screen here. I'm back onto the main screen. Everybody's back onto the main screen. You second and moded back to the main screen if you hadn't yet. And we're going to go get that y1 again. Where do we go to get the y1? Vars, then what? YVARS, and then what? Function, and there it is. And I'm going to do like a function notation with this. So I'm going to do y1, and I'm going to do a parenthesis 2.15. So what that's telling the calculator is to plug 2.15 into x for the equation stored in y1. So I would have, my line tells me that I would sell approximately 104 cans if I charge $2.15. Is everybody okay with that? Okay. What we just did there is called interpolation. So what we did was we used our line of best fit to approximate some value of x inside of the data set that we have, right? We use the x's from 125 to 250. You guys see that? If I asked you to approximate how much or how many cans we'd sell if we sold it for $1 or $3, notice that's outside of our data set that we used to build. That is called extrapolation. Which one do you think is more reliable, interpolation or extrapolation? Interpolation. Extrapolation, you can get yourself into big trouble, because what are we assuming here? Well, that this linear relationship is going to continue forever, right? If I sold these cans for $250 a can, how many am I going to sell in the real world? 0, right? Nobody's going to buy a can of food for $250. Everybody agree? But what's the model going to spit out? Probably some big negative number, right? Does that make any sense at all? No, right? That's where an example of extrapolation getting us into trouble, because while this function behaves very linearly inside of this data set, for big or small values of x, it may not behave linearly at all. Everybody agree? How many cans would you expect to sell if I charged $0? Infinitely many, right? As many as I put out there, somebody would take. If you're saying so this is free, anytime somebody's giving something away for free, somebody's gonna take all of them. Because they're gonna be like, hey, free thing. You know what I mean? Even if they don't like it. It's like, I hate green beans, but they're free. I'll take them all. You know? I don't mean to hate on green beans. I was just an example of a canned food. I had them for dinner last night. Not canned, but just green beans. There was other things for dinner also. It was just a big plate of green beans. Yeah. Yeah, just one big plate of canned green beans. It was delicious. And all my vitamins for the day. Okay. Does everybody feel okay so far? What if I asked you to tell me how much should I charge to sell 50 cans? How would I do that? There's some plugged into the power strip right there. How much should I charge to sell 50 cans? So I've been given a y, and we want to find an x. Everybody agree with that? So here's what we'll do. We'll go to our calculator. Press the y equals button. In the y2 spot, we're going to type in our y value, which is 50 cans. And then we're going to hit graph. What do you notice here? I didn't see the line for y equals 50 come in. Why do you think that is? It's too zoomed in. Very good. So what I'm going to do is I'm going to click on Window. And now which thing am I going to need to change here? Well, I think that if I look at my commands here, my y minimum is set at 58. What can't I see? Y equals 50, because the minimum thing is 58. So like the line I'm looking for is below my screen, right? I need to change that y min to be something less than 50. How about we just make it 0? Let's hit graph now and see if that does it. Everybody see we can see the line now. Are we sure we have the intersection? Looks close, but I'm not positive. Are you positive? So I'm going to move the screen over a little bit to the right so I can see that intersection clearly. So I'm going to go to my window. What do I need to change to move the window to the right? I need to make my X max bigger, right? The right side of the screen is left and right is X. The right side is the max. The left side is the min. Does that feel okay? So let's just change that from 2.65 to 3. Boom. There's my intersection, right? Second, trace, intersect command. Asks me 3 questions, but guess what? First curve, second curve, and guess. How many curves do I have graphed? Just 2. How many times do they intersect? Just once. So does any of this really matter? No, I'm just going to press enter 3 times really quick. So it looks like $2.67 or thereabouts. Oops. Right, there's my X. What do you guys feel? It's all right? Okay. Yeah, but this is all like just getting comfortable with the calculator, right? If you're good with the calculator, there's nothing to screw up. It's like set up and use the calculator to do the math. So guess what? In the real world, do things always behave linearly? No, right? There's other options. So what other ways might things behave? You could have like something like this. What's that? Yeah. What if it looked like this? What would that be? Close. What type of function makes a parabola? Starts with a Q. Yeah. What if it looked like that? That's a degree 3 polynomial.
We might be this, but we'll try to make it.
And if you're not sure, you can use a power function, which kind of is good for anything. So the other thing we'll do, bless you, is we might want to use a different model other than just linear things, right? So the way that we can determine, like, hey, what might make a good model here is we can look at what's called the coefficient of determination. Which is the R squared value. So remember when we did the ln reg and we also got the r squared value? Right? What if we did something crazy with this data set? Maybe we'll do a different kind of regression on it and see maybe it'll be a better fit than the linear one we just did. So all of our regression equations live in, to get to those, we press Stat, go over to the Calc tab, and look at our list, right? We have ln reg, which we already used, quadratic regression, if we thought it looked quadratic, or cubic regression, if it looked like that sideways S, or quartic, if it kind of looks like a W. There's another ln reg. I don't know why they have two ln reg versions on here. This is a logarithmic. ln reg is for logarithmic regressions. Exponential reg, power regression, logistic regressions. We'll talk about that later. And they even have trigonometric ones like sine, and then they have a manual fit option. I've never actually tried to use that. Let's say that we tried to do this as a quadratic regression. Now, would I really want to do that given the scatter plot we saw? No, right? But let's just do it for funsies. So I pick quadreg. We're just doing examples right now. But yes, you could do any of them, right? They'll all work. They'll all give you a number. The point, what we're going to do now is we're going to look at the r squared. Before it was like 0.92. I would suspect this one to be a little worse. And we're going to store that equation into, let's put it in y2. The r squared value, turned out to be maybe a little better. Let's look at the graph here. There's my line. There's my parabola. That didn't do too bad, right? As a fit, you can see it's actually a little bit better fit than the line. Right? You guys okay? See what we're saying? It's probably user error.
Yeah, probably, but it's a straight line. Why is there just, it looks like a straight line across the bottom?
That's probably the y equals 50 there that we're using before to answer the question.
So just like clear that?
Sure, if you'd like. All right. Little bit of vocab here. So this term of a power function is probably not one that you're familiar with, right? Does that sound familiar? No. But exponential and logarithm, those are like things that you did, right? But like what the heck's a power function? I don't remember. Did we do that? I'm not sure. Well, let's define what we mean. So a power function is something of the form f of x equals k times x to the a. Well, Mr. Kulik, isn't that just a polynomial? No. And the reason why is the a, the exponent, can be positive or it can be negative, and it can be a decimal. It does not have to be a whole number. Everybody's okay? All right. Vocabulary-wise here, we call a the power, not surprising, and k we call the constant of variation. So there's a bunch of power functions that we're already kind of familiar with. So for example, the circumference of a circle, c equals 2 pi r. our constant of variation is the 2 pi, and the power is 1. Everybody okay with that? Notice that's also technically a polynomial. Can you guys stop talking and put your phones away? I didn't know you already knew how to do this. Would you care to come up and finish up the lecture for today? Okay, then let's just try to stay focused, please. Area of a circle also could be considered a power function. The constant of variation is just the pi. The power is the 2. Everybody's okay?
How do you know between a function and
It could also be considered a quadratic function, for sure. Not wrong to say that, but if it's like describe the constant of variation, the power for this power function, well, it's, you know. But yes, that's a great point. What about, what is this? Temperature, what's that? Is it Dalton's law? Is that what it is? Chemistry people doing gas stuff? V equals K over P? No? Pressure and volume is Boyle's law. I don't remember. So here, again, the K is our constant of variation. And the power is -1, because K over P is really the same thing as K times P to the -1. K over P is Boyle's law? Temp or volume is, okay. Oh yeah. Oh, I read temperature and I got, is, okay. Yes, this is Boyle's law. Of course, volume and pressure. That's why when you're diving, you have to exhale on your way up so your lungs don't explode. The pressure changes, the pressure lessens, so the volume expands of the air in your lungs, so you blow up. If you're deep sea diving or whatever. Anyways, so let's say we have the power function V is equal to 4/3 pi r cubed. What's the constant of variation? It's not just pi. Yes. And what's the power? The exponent. 3.
Is the constant of variation just the
Coefficient. Yep. What do you guys think? Yeah.
We have to memorize all that stuff.
Yes. Yeah, the calculator parts you will need to be able to do for the test. The good news is we'll do some more practice here in a minute with the calculator. So here's another example. Use the data to create a scatter plot. Okay, let's do that part first. Stop. Go. Take your calculator out. Do it. Scatter plot me. Practice trying to do it. If you don't remember how to do something, ask your neighbor. If your neighbor doesn't remember, ask me.
How do you clear the section?
So I move my cursor. So see my cursor here?
Yeah.
I move it up onto the title and press clear and then the down arrow.
Okay.
Oh yeah. Edit. I don't know. I just
Oh. We gotta get rid of the wild one.
I did. We don't need it anymore.
I think it was messed up.
wait, hold on. Where is Zoom stat? Wait, this is not on Zoom stat. Zoom app? Wait, where is this Zoom? This it? Okay, yeah, here's that.
Oh, and then I go Zoom stat,
Okay, that's
and then I go to Kelp. And I do that. Kelp.
This is what your scatter plot might look like.
yeah.
The next part says create a power regression curve to model the data. So do that next.
Wait, what did you say?
Create a power regression curve to model the data.
So that means
So what do I do if I get that? Am I done?
It says power regression, not linear regression.
Yeah.
And then, and then you press second.
You already have one.
Oh, and then Zoom stat.
Creating power regression.
Oh, wait.
So there's my power regression. Yep.
After I have like the dots, how do I?
Exit off to the main screen.
Yeah.
Stat over to calc,
Okay.
and then go down and find power reg.
Why did you give this secret?
And then is this when you do like the Y thing?
Mhm.
Is there a reg you gotta find?
I would, because look at my picture that I just made. How do you think I got that?
And then the Y thing is
Why is it
that,
Y?
and then
I
variable.
stored it to Y1.
Store the Y?
I always do.
It'd never be the,
What's up?
it'd never be like the X. Then,
Correct.
Why do I have multiple lines on it?
Did you delete the stuff in your Y equals menu from before?
And then now it's no lines.
Huh?
Now it's no lines.
weird.
Okay.
Go back to the power.
Mine was like very simple.
Did you do zoom stat? Okay. And you have points though, right?
Yeah.
Did you do this? Did you make a power regression?
Yeah.
Did you store it to Y1? Did you do the store reg EQ?
No, I didn't do that.
Vars, Y vars function Y1?
And then, oh, up here.
And then now you go.
When I store them, and then I go in that.
What's up?
After I hit the Y1, what do I do after I hit texture?
Is the answer 60,000?
Mary, you have to do it when you're doing the regression.
Yeah.
Where it says store reg EQ, that's where you put the Y1 at. And then part 3, it asks, use that curve to estimate the orbital period of Neptune, which is 4,497 gigameters from the sun.
Oh. Actually, how do you get to that from?
That's 60,000.
Don't you just hit mode and then area? I don't know.
That's 60,000, right?
Mm-hmm. Yep.
What does that give you that you have up here?
That's the answer to the final sentence.
That is 60.
Mm-hmm.
Error, bro.
What is putting that number into like the L into the Y2? Like what we did in the last.
So that was if we were given a Y and asked to find the X. Here we're given an X and asked to find the Y, so I just have to plug the X into the function.
Okay, so you don't have a.
Right.
I got the right calculator the power rate. So what do how do I store it?
Where it said store reg EQ in the menu, when you did the power reg, you had to put the Y1 there. So right here, where it says store reg EQ, that's where the Y1's, where you put the Y1. Right? That's how you store it.
Oh.
Try this one. So this is all in OneNote, right? You could literally do this. I'll put keys in later. That's what I would do. I sure hope so. Ha 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 ha. Got ya. you picked the a plus bx equation instead of ax plus b. It's fine. You just have to look at Reese. You just have to look at the top. See the equation at the top where mine says
I see it. I clicked
a.
that one.
Yeah, so just write it, put the a and the b in the right place, and you're fine. You know what I mean? Just whatever the equation says, put it wherever it's supposed to go. No?
What? Oh, sorry. I'm from Alex.
You see that?
Oh, there. That's the only thing I want. Yeah, I feel like a big or like a
Yeah. Bro, I wasn't even paying attention, bro. I just waited and yes, you did, dog.
To get the scatter plot to go.
Notice they didn't ask for the scatter plot in the question, right? So I just went straight to making my linreg. Makes sense. Reading. Ah! Maura. I sure hope so. How are we doing on this? You getting the hang of it? Catching up? Just takes practice, guys. Get comfortable with the calculator. You know what I mean? Once you got it, it'll be easy. What was that? Procreation Day?
It's a thing in Russia.
Oh.
How did you do the last part? Wow, the user.
It's on my calculator.
Why do you do 18?
Read the X years after 1997. 2015 is 18 years after 1997.
All right.
Oh, that's true. I didn't done this.
I'm on to the next one. Ugh, I shouldn't have done anything. I cleared that out. I shouldn't have cleared it. Look at the X values. They're all like almost the same. Bless you, bless you.
Wow, might. Maybe.
Yeah, what's up, homie? I sure hope so.
This is like big egg morning. I think it's a I think it's Instagram today. It's give it a follow.
What? You've killed 2 other eggs?
Don't tell anybody. She dropped her egg right before she walked on the site yesterday, actually. Yeah, she already knows about 2 of them.
Are you gonna print out another big bag or anything?
Yeah, it's just not that hard. It fell out of the box, and then the first time it literally fell off my desk.
Sorry, that is so funny. Maybe that's why you do it. Dad, she's shaking around like that. One face is the best. So, are you like failure? Dad, what? Oh, yes. She forgot her egg the first time. I have my egg.
Yeah, I also forgot my egg.
Sydney,
Sorry.
It's so horrible.
your poor little egg.
Isn't it like exhausting to draw it all out?
I get it, exhausting. Oh,
More I forgot to decorate this one.
Horrible joke.
Is that not exhausting? I feel like it
it scrambles my brain.
It's so stupid.
It's over so easy.
Wait, is that not fun? Wait, oh, you
But just think about the sunny side up, you know?
Like having to draw it on.
No,
I'm sorry,
because
I'll
it's
take
like-
a joke.
I literally just like cut a picture of his face up.
Yeah,
Finger
on it.
Hide your mind. Jacob is not a face on right now.
Oh, are we done?
Because she broke the
Look, I did all of
I
my
grabbed him this morning.
You got it?
I got it.
You can be the calculator wizard.
Yeah.
We have to do power right.
Okay, I feel like I know.
Says Linrag.
I'm not. Okay, let me
I'm like,
oh, my boss card. I like to do one better than today. What?
I know. It's like all the
Yeah.
Okay, if I remember.
Don't even if you remember.
You can kind of viral for 2 minutes.
What?
Just kind of viral for 2 minutes.
Oh, no, I just want to study. Your friend, are you coming tonight?
Yeah, FYI, the homework, you guys should be able to do all of it, 1 through 31.
What for 31?
Yeah, it's all calculator, homie.
Ask me. Ask me if I.
Yeah, Allie, you gotta take that homework quiz
What
yet.
time is it?
They haven't get on that.
Said, what time does it start? 7?
Um,
This is funny, it's me in there.
This was the whole chapter, what we did today.
For this last one, I got that.
Cute.
I'll give you 0 point test, like, fake story.
Wait, this is actually.
Probably just forgot.
Oh.
Now I'm a 50. Mary's multiple choice was so hard.
Mary, I actually
Well, I'm actually not doing it this week. I never done that one.
And if you redo everything, it should probably work out for you.
And now I gotta redo everything.
You have to redo the Linrag, right? Because it won't adjust automatically. Hey,
Yeah.
again, this was it for chapter 12. What are we going to do?
I'm about to ace my test.
What do we have to what do we have to do before a test?
No hard.
No.
Before that, homework quiz. I would try to feel pretty comfortable on my calculator. Okay? Get comfortable on that calculator. Do some practice. Francesca's like, this is easy because it's just the calculator. So all you got to do is know how to use this thing.
I just kind of